Alright, so for part B, we have the same tank, but now we're going to replace the liquid inside with something of a higher indice of refraction. And how's that going to change the interference pattern? That's what the question's asking. Okay, so let's think about this. Whenever we shoot light into something that's of a different indice of refraction than a vacuum, its speed drops. And that new v is given by lambda times frequency. And we know that beforehand it was moving at the speed of light given by lambda times frequency. So something has to change here. It's not the frequency of the light, it's actually the wavelength. So this is going to be the new wavelength, and we're going to call this the old wavelength. We also know that this v is given by c over n. And what's c? C is lambda naught times frequency over n, and that's going to be by lambda n times frequency. And I can actually come with a relation here and show that lambda naught equals lambda nu times n. And I know from this equation that n must always be greater than 1. So that means lambda naught over lambda nu equals n and is greater than 1. So that means the old wavelength must be greater than the new wavelength, meaning the wavelength actually dropped when we shot it into this new medium with a higher indice of refraction. So lambda decreases. What does that mean for the interference pattern? Well, we know that d sine theta is given by m lambda. So I want to see how does the angular spacing between the fringes change by shooting into this new liquid. I know that, well, actually, we're going to solve for theta. Because the angle is so small, I'm going to approximate sine theta as just theta. So d theta is approximately m lambda, and theta is m lambda over d. And since theta decreases, since lambda decreases, the angular separation must decrease. So my answer would be, since lambda decreases by the above, the angular separation of the pattern decreases as well. Obviously, I kind of ran out of room here. I have to write a little bit longer. I'd probably describe what I wrote here. But you start off with a relationship given the speeds and the wavelength and the frequency of everything, and you can show that the angular separation must decrease for the new interference pattern.